Hi, welcome to Pachyderm. Today we're going to be showing you a quick introduction to the core concepts of Pachyderm and the challenges that our software solves, as well as giving you a quick demo of the Enterprise Edition. To start off talking about some core data science challenges that we see in the industry all the time. So especially when you're talking about machine learning, everybody tends to be focused on the training of ML and AI models, as well as kind of the inference steps. But in reality, when you're dealing with a large production scale pipeline, there are a ton of other important pieces that come into play. This includes everything from data ingestion and data cleaning, and as well as feature engineering and hyperparameter search. And then eventually you get to the training and testing steps and optimizations of your model. And then finally, you need a way to deploy that into production, run inference, and do a bunch of post-processing and visualization to test how your models are actually doing in the wild. At the end of the day, the challenges here come from the fact that code is constantly changing, right? Every step along that pipeline is a different piece of code, oftentimes written by different people within your organization. But in addition, data is also constantly changing. Not only does this mean that data formats or inputs can be changing, but also small code changes at the top of your pipeline can actually have drastic effects on downstream stages of your pipeline. What this really boils down to is that managing pipelines gets to be really complicated. Data and code often are changing and need to be kept in sync so you have an understanding of which results come from which pieces of code and data. So this leads us into the core concept of Pachyderm and how we solve these challenges. At a high level, here are the major things that Pachyderm does. We do data versioning. We allow you to build containerized analysis and then chain that analysis into data pipelines. Each step in a pipeline is individually scalable based on the performance characteristics you're looking for. And then lastly, we wrap it all together with data provenance, which allows you to track how that data and code work together to create a given result. Let's dive into each of these one by one. First is data versioning. Pachyderm provides data versioning semantics similar to those you're familiar with code. So just like in Git, Pachyderm actually organizes data into versioned data repositories. A given data set would, for instance, be a repository, and that repository would have a commit structure and a basic file layout, just like you would if it was a Git repository. Because that data is now versioned, Pachyderm allows you to identify and revert bad commits and changes to those data sets. You can also identify diffs and understand what data has changed over time and get this full historical view of how a data set has evolved. This also works for versioning intermediate steps, such as your model binaries, what parameters you used, all sorts of intermediate pieces that you might need to track. And at the end of the day, what this allows you to do is reproduce any specific processing from any historical state of your data. Second, we have containerized analysis. So if you think about a large pipeline where you have data, code, right? Pachyderm allows you to use any language or libraries or frameworks that you want for each of your transformation steps within your pipeline. This is because we use Docker containers as kind of that core primitive. So if you can package up your code into a container, Pachyderm can now use that to process data. That might mean that you have Python code working, passing information to R code, which passes information to a bash script. It doesn't matter. Pachyderm gives you a complete ability to kind of chain these pieces together. It also means that if you can get something to work locally, Pachyderm can easily let you port your workflow to a production environment. Pachyderm then lets you take these and turn them into full data pipelines. So an example I have here, which might be a simple training step, I would have some training data set. I would then have my modeling code, which outputs my versioned model binaries. Then next I have an inference step that takes in that model as well as observational data and creates and makes inferences. In Pachyderm, pipeline stages are triggered by new data. So if I add, let's say, a new day's worth of training data into my training data set, that'll be a new version of my training data set, which will automatically trigger a new run of my modeling code, output a new model, which now my inference step will now use. In addition, if I go ahead and update my modeling code, Pachyderm will now see, well, I have the same training data, but my code is now different. I want to have my head commit of my training data, use my latest version of my modeling code, and have that be the results, and have that create the results that I need going downstream. Really what Pachyderm allows you to do is put data in the top and know that things are going to flow downstream and trigger automatically in a full pipeline. And that every step of your pipeline is always going to use the latest version of data and the latest version of code, but you can always go back and look at historical combinations that were used and understand previous results. Every step in a pipeline can actually be individually scaled based on the resource requirements and performance characteristics you're looking to achieve. So for instance, if your modeling step needs some GPU nodes, but your inference step is something that's highly parallelizable and you just want to use high memory or CPU nodes, this is totally achievable in Pachyderm. You can automatically scale up the number of workers to process data in parallel and select the appropriate resources, whether it's CPU, memory, GPU, on a stage-by-stage basis within your system. This also allows you to quickly scale up and down your workloads based on the amount of data or how compute heavy your particular stage in your pipeline is. And finally, we tie these all together with data provenance. So if you look in this diagram, we have different pieces of data code that flow downstream. Pachyderm actually allows you to look at some result, let's say at the end, and say, this looks weird. Show me every version of code or data that went into creating this result. And Pachyderm actually tracks all of that metadata and can display that information for you. So as an example, if you're working in a compliance-heavy environment, something like finance, bioinformatics, or you just have GDPR requirements, you can take a result from, let's say, even a year ago, and Pachyderm can show you every version of code and data that went into creating a given result, all the way from raw results and every version of data and code in between. Lastly, let's give you an overview here of Pachyderm's architecture before we dive into the demo. So Pachyderm is deployed on Kubernetes. We use Kubernetes as our container scheduler. It works on the cloud or any on-premise Kubernetes cluster, as well as multiple flavors of Kubernetes such as OpenShift or PKS. Pachyderm at the storage layer uses any generic object store. So if you're in the cloud, this can be S3 or Google Cloud Storage. If you're on-prem, this could be Minio, Ceph, or Swift. You would allocate a object store bucket to Pachyderm, and we actually behind the scenes are content addressing all of the files that you put into our system into that object store. Pachyderm itself is actually just deployed as a containerized application on your Kubernetes cluster, just like anything else. And then finally, data scientists can create pieces of containerized analysis, such as Python, TensorFlow, Bash, R, whatever they need, pass that information, those pipeline definitions, to Pachyderm, and Pachyderm will then chain them together, make sure the right data is given to each stage of the pipeline, and have those scheduled by Kubernetes so that they get the correct resources they need. Next, I'm going to show you a live demo of how we can do this in action. So here is the Pachyderm Enterprise dashboard. The demo we'll be showing you today is some simple image processing using OpenCV. On the right-hand side here, you can see my pipeline DAG. At the top, these blue hexagons are my versioned data repositories. And I can see my first one here at the top of my DAG is images. In my images repository, I can now see information about this data set. I can see how many files there are, how many commits, branches. I can also actually view the files directly. So for instance, in my images repository, right now I have 3 images. And I can see I have the Statue of Liberty, Star Wars, and this picture of a kitten. Remember, this is a versioned data repository, so I can actually go look at previous states of this data set. And so if I click on commits here, I can go see past commits. And for instance, I can go 2 commits ago and see that at that time, I only had a single file, which was the Statue of Liberty. Of course, Pachyderm is not storing this piece of information in there twice. Pachyderm actually understands diffs of your data, and so it makes sense that in commit 1, I had just this single file, and then in my latest commit, I actually have all 3 files. Of course, the Statue of Liberty is only stored once behind the scenes in my system. Next, let's talk about data pipelines. So these green symbols are your data pipelines. In Pachyderm, this is, as I said, defined by a Docker container. So I can see here that I've defined a Docker image. It's Pachyderm OpenCV. This is a public image on our Docker Hub. And I have a edges.py Python script built into that container that does some very simple image processing. Behind the scenes, what it's actually doing is just reading in those images in my input and then doing a basic transformation and writing that out here to the edges repository, which is this intermediate repo. And actually look at this intermediate repo and see these results. So you can see I now have edge detection on the Statue of Liberty, Star Wars, and this picture of a kitten. Finally, I have a montage step here. My montage step is actually taking two inputs, both images and edges, and creating a full montage view of all of them. Montage, on the other hand, is actually just using VTech ImageMagick as its base image, and it's running basically a big one-line bash script. If I click on montage, I can actually see what that result is, and you can kind of see a complete view here of all of my initial input images as well as the edge detected ones together. Now, we talked in Pachyderm about how pipelines are automatically subscribed for new data coming in. So in fact, I'm going to actually change over to the command line here and add some new data to my images repository and see what happens. Here in my terminal, I can actually see my Kubernetes cluster running. I've got the Pachyderm server, I've got the dashboard, and I've got a few pipeline pods that are running. And now I'm going to go ahead and add some more information to my images repo. I'm going to do that with a put file command, adding it to the images repo on the master branch. So now if we switch back over to our dashboard, we can see some new data has shown up. In addition to the images we already had, we now have Winnie the Pooh and this picture of a girl holding a flower. But automatically, as soon as this new data was added to the images repository, the edges pipeline noticed that change in data and ran a job to process it. So we have edge detection both on both of these images, and of course still have the rest of the data from before there as well. Now, one really important thing I want to point out is that Pachyderm is smart enough to only process the diff of the data. So if we go look at the most recent job, for instance, we can actually see that there was 1 datum processed and 4 datums skipped. This is Pachyderm being smart enough to know that even though only 2 new images were added, that the other 3 did not need to be reprocessed. And so in fact, in the first job, processed 1 of the images, Winnie the Pooh, and in the second job, processed just the girl with the flower. It didn't need to go back and reprocess any of the previous 3 images that were already there. Once edges was complete, then of course montage saw this output commit on edges and created a new montage job that now built a new montage view with all of the data together. Finally, let's talk a little bit about provenance. So in Pachyderm, if I, for instance, want to look at a version of montage and look at, let's say, the most recent commit, and I saw that this image looked weird for some reason, I could actually go into the dashboard and look at the upstream commits to understand which pieces of data or code went into that. So for instance, looking at the head commit in my montage repo, I can see that that came from this specific commit in edges and this specific commit in master, right? Or in images. So I can actually go back and look at the exact data that was there, and I can go back and look at the specific job that was run to create each of these pieces. So this is how Pachyderm allows you to track relationships between pieces of data throughout your system. You can know what commit in images was run through what version of the edges code, outputted a particular commit in edges, and then what commit in edges through what version of the montage code created a particular commit in montage. And all of these commits are actually linked together via provenance. So that concludes our high-level demo of Pachyderm. I'm sure there are a lot more details you'd love to learn about. Please come into our public Slack channel and ask us questions. You can feel free to email us at info@pachyderm.io or find us on GitHub, and we'd be happy to help you out with any issues you have. If you'd like to run this exact same demo I showed you here, we have our beginner tutorial that'll walk you through exactly this pipeline as part of our documentation. Thanks, and looking forward to talking more.